All right, guys, what we're going to do today is we're going to use some of that Algebra 2 knowledge of inverses and apply it to trig. Okay, so a couple things just to remind you about inverses. To find the inverse, okay, of a function, the original has to be 1 to 1. So to be 1 to 1, it has to pass the vertical and the horizontal line test. The vertical line test and the horizontal line test. If it isn't 1 to 1, and this is what we saw in the notes from yesterday, we're going to restrict the domain. So to find the inverse of a function, we will simply switch x and y and solve for y. Also, something to remember, if you go from your original function to your inverse, the domain and range switch. They flip. Okay, so here's our sine graph. Okay, our standard sine graph from 0 to 2 pi. Now, when you look at this clearly, it's a function. If you do the vertical line test, it passes every time. However, it fails the horizontal line test. So that means this is not a one-to-one function. So what we're going to have to do here is we're going to have to restrict the domain. So when you look at this, clearly this is where we start. You're good to go to here, but once you hit this maximum and go down here, that's where it starts to fail. Okay, that's where it's going to fail the horizontal line test. So sine actually, remember, it goes on and on forever in both directions. So it's going to go this way as well. Oh, that looks awful. Sorry. Okay, where this is negative pi over 2. So we're actually going to go back, whatever mathematicians a long time ago, crazy people, okay, decided, let's go back and we're going to restrict it. We're going to cut this off. That's supposed to go through negative pi over 2. Sorry, guys. To pi over 2. So if we look at just this middle section here, we can restrict it so that way it passes the vertical and the horizontal line test. So we're going to cut off basically from this minimum up to this maximum. Okay. So let's come down here and do a little bit more with this. So if we wanted to find the inverse of sine x, so remember, we basically, okay, switch x and y and resolve for y. So to get rid of sine, we would have to do sine inverse. But what you do to one side, you have to do to the other. So we're going to be left with sine inverse of x equals y. So that's how we find the inverse algebraically of sine. So the inverse is going to be sine inverse of x. Some people write it as arc sine of x. That means the same exact thing as sine inverse. So if you ever see arc and then a trig function, it's saying the same thing as the inverse. Okay. So let's take a look here. So if we look at the section that I just cut off from above, from negative pi over 2 to pi over 2, you can see that it is 1 to 1. So we cut our domain from negative pi over 2 to pi over 2, including those, and our range has always been negative 1 to 1. So now, if we were to graph the inverse of this, remember, we flip the ordered pairs. So this would technically be the ordered pair negative pi over 2, negative 1. So it's going to become negative 1, negative pi over 2. The negative pi over 2 is like negative 1.57-ish, so it's going to come like here-ish. Okay, 0, 0 stays there. And then this was the ordered pair pi over 2, 1, so it's going to become the ordered pair 1 pi over 2. So this guy is going to, oh, I'm so bad at drawing these. Okay, I'm going to try that again because that was horrible. Okay, so it's going to go something like this. They're not actually going to cross there. I'm just so bad at drawing these. And they should reflect across the line y equals x, just like inverses. Because I'm so terrible at drawing these, okay, this is the normal sine graph, and this is what sine inverse looks like. So you can see how when you cut it, how it reflects appropriately, unlike my horrible drawing. Okay? Okay. So now domain and range flip. So now our domain is negative 1 to 1, and our range is negative pi over 2 to pi over 2. So this is going to have implications when we're solving. So if you think about it, if your range, okay, is negative pi over 2 to 2, when you think about it, okay, this is 0, this is pi over 2, negative pi over 2 is down here. So the only solutions when you do sine inverse are in quadrants 1 and 4. Specifically in quadrant 4, they have to be between negative pi over 2 and 0. So we'll see what happens there when we do a couple problems. Now, if we go through and we do that same exact idea for cosine. So this is a standard cosine graph. Notice it fails the horizontal line test. But look, this one, if we start here and we go to here, we can cut it off from 0 to pi. So we're now going to make this go from 0 to pi. The range clearly is still fine. Okay? So in order for this to pass, we're going to cut this one here. Once again, crazy mathematicians long time ago decided to do it like this. So once again, to find the inverse, we switch x and y, do cosine inverse of each side, and we get that our inverse is simply cosine of inverse. Cosine inverse of x equals y. So this is the graph of cosine where we cut it above. I'm going to try my best again. So this is the order pair 0, 1. So it's going to become 1, 0. Oh God, I'm so terrible at these. This is pi over 2, 0. So it's going to become 0 pi over 2. And then this is the order pair pi negative 1. So it's going to become negative 1. Oof. God, I'm so bad at these. Pi. And it's going to do something like this. So once again, you can see that they reflect across that line y equals x. I'll show you a picture in Desmos. So here's the whole cosine graph, and here's what it should look like. Now, once again, you're gonna have that line y equals x, which they reflect around. Okay. So we restricted the domain from 0 to pi, and the range is always negative 1 to 1. So now they flip. The domain of the inverse, okay, is negative 1 to 1. Okay, negative 1 to 1. Clearly my drawing is not to scale. And my range is now 0 to pi. Well, this is going to have implications when you use cosine inverse. Here, your only solutions are in quadrants 1 and 2. If you think about it, here's 0, here's pi. Okay. So now, let's use some of these ideas. So, key thing, I know I have a lot written here. I just had it all set up to save time in the video. You'll need your special right triangles, your ASTC, your unit circle. And this I just copied from above. You want to remember your range restrictions when you're evaluating this. So if you apply sine inverse, your only answers can be in quadrants 1 or 4 from negative pi over 2 to pi over 2. If you apply cosine inverse, your only answers can be in quadrants 1 and 2 from 0 to pi. Keep that in mind. Okay, I'm going to do exact answers, and I would want you to do exact answers for these as well. So sine inverse of 0. So you're asking yourself, okay, 0 is technically from a trig ratio, so my answer should be an angle. So anytime you're doing an inverse trig, you're doing an inverse trig to a ratio, and your answer should be an angle. Okay, so think about this. That's clearly from our unit circle. Sine is y over r. R is always 1. So we got to find where is y 0 within these range restrictions. Okay, well, right here. Here's where y is 0 within those range restrictions, and that would just be 0. Okay, arcsine of 1, also from the unit circle. We're looking, r is always 1, so we're looking for where is y 1? Well, from negative pi over 2 to pi over 2, well, that would be up here where y is 1, so that would be pi over 2. Sine inverse of 1.5. When you see that, an alarm should go off in your brain. That value is greater than 1. If it's less than negative 1 or greater than 1, that's outside of what we can do. Okay, so this has no solution. It's too big. You can't do it. Okay? All right, I'm going to skip just some of these just to save time. Cosine inverse of 1/2. So when you look at that, that's the trig ratio. We're trying to find the angle. So if you had 1/2 for cosine, that would be a 60-degree reference angle. Okay, cosine over hypotenuse. Now, notice your restrictions here are all in terms of pi. That means your answer should be always in radians. Okay, so that would be some form of pi over 3. Now, the cosine restrictions are from 0 to pi. Since it's a positive 1/2, it would just be 1 pi over 3. Now let's pretend for a second that it were a negative 1/2. Well, cosine's negative in quadrant 2, so that would have been 2 pi over 3. Okay. Sine inverse of negative root 3 over 2. So also a 60-degree reference angle, opposite over hypotenuse. So it's some form of pi over 3. We got to figure out what the number here should be. Now, it's negative. Sine's positive in quadrant 1, so the only other answer based off of our restrictions should be in quadrant 4. But if you go this way and you say that it's 5 pi over 3, is that between negative pi over 2 and pi over 2? No. So what you need to do, instead of going counterclockwise, go clockwise and make it negative pi over 3. That's important. Okay? Let's try another one. Cosine inverse of negative root 2 over 2. So that's from our 45, 45, 90. So it's some form of pi over 4. Okay, now since it's negative, that means we want the quadrant 2 answer. which would be 3 pi over 4. You really have to pay attention to your restrictions. Okay? Excuse me. Now, look at this bottom one. Sine of 3 pi over 4. What's different about this one compared to all the others? Hopefully a couple things go off in your brain. There's no inverse. And this is an angle. It's 3 pi over 4. That's not a trig ratio. Okay. So this is just what we've always done. Sine of 3 pi over 4. So it's a 45-degree reference angle. Quadrant 2. So that would be 1 over root 2 if we rationalize it, root 2 over 2, and sine is positive in quadrant 2. So you need to be able to recognize when you're doing inverse or when you're just doing a normal one. You also need to recognize the inverse you do of trig ratios or side lengths, and the answers are angles. Here, when you're doing just straight sine, it's of an angle, and your answer is a trig ratio. Okay, let's do a couple compositions here quick. So compositions, it's just like when you would compose things before. If I gave you a function f and g and I said, let's do f of g of 2, you would start on the inside with g of 2. Same idea here. Let's start with sine of pi over 3. So 60-degree reference angle, root 3 over 2. Quadrant 1, so it's positive. Now let's do the sine inverse. So you'd come over here and you'd say, okay, to get root 3 over 2, it was a 60-degree reference angle, so some form of pi over 3. In quadrant 1, paying attention to your restrictions for sine, you get that answer. Well, you're like, well, wait a second. Shouldn't those cancel each other out and you just get the answer pi over 3? Be careful, does that always work? Let's try this one. So cosine of 2 pi over 3. So 60-degree reference angle, quadrant 2. So that'd be 1/2. Quadrant 2 would be negative. Cosine inverse of negative 1/2. So you'd come over here and you'd say, oh, okay, 60-degree reference angle. So some form of pi over 3. Since it's negative, that would put us in quadrant 2 for the restrictions for cosine. So 2 pi over 3. Oh, well, it worked again. Let's try this one. Sine inverse of sine of 7 pi over 4. So if you start on the inside, sine of 7 pi over 4, 45-degree reference angle. So you get root 2 over 2. That is in quadrant 4, so it should be negative. Now when you do sine inverse of negative root 2 over 2, so you'll say, okay, it's a 45-degree reference angle, so it's some form, of pi over 4. Oh, crap. Pi over 4. But it's negative, and when you pay attention to the restrictions of sine, the only places that you can deal with are quadrants 1 and 4. Well, it'd be negative in quadrant 4, so it should be 7 pi over 4. No. That's not between negative pi over 2 and pi over 2. So you're actually, sorry, there's this random line down here still. So you're actually going to say it's negative pi over 4. That's kind of like this guy up here. Okay? You've got to go clockwise to get down to that quadrant. All right, let's try this one where they're not the same exact function. So start on the inside. Sine of 3 pi over 2. So we need our unit circle. 3 pi over 2 is here. So that's the ordered pair 0, negative 1. Okay? Y over r, we would get cosine inverse of negative 1. Then cosine inverse of negative 1. So that's x over r. So where is x? Negative 1. Over here at pi. Now, is that within the restrictions for cosine? Yes, it is. 0 to pi. We are good to go. All right, let's do one more here. So, sine of 4 pi over 3. So, 60-degree reference angle. Quadrant 3. So, we get root 3 over 2. That would be negative. And we do arc sine, which is the same as sine inverse. It's up to you how you want to write that. It doesn't really matter. So, once again, that would be a 60-degree reference angle. So, some form of pi over 3. But we want the negative, so that's in quadrant 4, so it'd be negative pi over 3. Now, here, this is important. If sine inverse and sine, so if you do sine inverse and sine, and that x value is between negative pi over 2 and pi over 2, then that's just your answer. If it's outside of that, do the whole thing. If you have cosine inverse and cosine, and the x value right here is between its restrictions of 0 and pi, that's just your answer. If it's outside of that, you got to do the whole thing. Now, for a calculator, you can literally, if you have crazy decimals like this, you can just type it in your calculator. So you would go to second, and then if you see right above the sign, you'll see sine inverse. So hit second, that sign button, and type that in, and you should get, running out of time, sorry, 0.2610. Arc sine, same operations. You can literally type these right in your calculator. Okay? All right, I will give you some practice. I hope you guys are well.